Hello, and welcome to the opening of our new Soil Foundation Structure Interaction Facility, or SoFSI for short. My name is Professor Ian Bond. I am the Dean of the Faculty of Engineering at the University of Bristol. We had hoped to have this event in person to allow you to get a real sense of what this new facility looks and feels like. But unfortunately, this has not proved possible due to circumstances beyond our control. So this new large-scale test facility is located in the University of Bristol's green and spacious Langford campus. It's located just south of the city in North Somerset, as we needed both the space and the ease of access that would be difficult to provide in a city centre location. So what is the Soil Foundation Structure Interaction Facility? It's a £12 million national laboratory funded by the Engineering and Physical Sciences Research Council as part of a £150 million programme entitled the UK's Collaboratorium for Research on Infrastructure and Cities, or UKCRIC. SoFSI is one of 10 national laboratories funded to underpin the renewal, sustainment and improvement of infrastructure and cities in the UK and elsewhere. You will hear more specific details about SoFSI and UKCRIC from my colleagues shortly. So what does the opening of SoFSI mean for the Faculty of Engineering at Bristol? Well, we undertake research on a competitive global stage, and SoFSI provides another platform in helping us remain at that highest level. It will further support the education, training and knowledge creation for the next generation of engineers and researchers as we develop the future talent pool the country needs. It will be a significant step towards a smart, right first time, efficient use of resources, critical in a resource-constrained world. Finally, it will support the future development of UK's national infrastructure, which has never been more important as we pivot to creating a net zero sustainable economy. We have been working hard recently in the faculty to focus our research on a more thematic framework. This includes themes on infrastructure and transport, energy and environment, and SoFSI is well positioned to support our work in these endeavours. I will now hand over to my colleague, Professor Anastasios Sextos, Professor of Earthquake Engineering, who will outline some of the research capabilities of this new facility.
Thank you very much, Ian, Professor Bond. Vice Chancellor, Professor Brady, Dean Professor Bond, distinguished virtual guests, it is with my great pleasure that I welcome you today to the grand opening of the new National Facility for Soil Structure Interaction here in Bristol. This has been the outcome of a collective effort of the last 5 years that started as part of the UKCRIC framework, an investment in the UK of £140 million on critical infrastructure research. Since then, many things have changed. This is because the world is evolving rapidly in a non-linear way. It accelerates faster than ever. We think we're resilient, but we're not. The pandemic taught us how unprepared we are, the hard way, unfortunately. The climate is changing very rapidly. We design our structures for extreme events, yet every time a flood happens, a storm, an earthquake in some regions, infrastructure keeps on failing to meet the stresses imposed. The built environment is increasingly complex. The supply chain is interdependent, the surface demand very dynamic. The infrastructure is exposed to multiple hazards, man-made and natural, that is very hard to predict in advance in time and in space. And above all, like the human body, structures age. They can even fail and collapse without any additional load just because we don't maintain them properly. This has an enormous social cost. But it's also a period of opportunity, particularly in the UK. The UK has announced a £160 million investment to build floating offshore wind ports and almost £1 billion in new factories for the offshore wind manufacturing sector, plus another £500 million towards advanced nuclear technologies. Smart motorways with radar technologies are upgraded throughout the UK. High-speed train 2, HS2, Britain's biggest infrastructure project, is progressing at pace. The energy and transportation sector are really booming. At the same time, more than £5 billion are to be invested in the next 5 years to boost the resilience to communities against the increased risk of flooding and coastal erosion because of climate change. But there's one problem with this. The problem is that funding is necessary, but not sufficient for resilience-based engineering. The main problem we face as engineers is the high uncertainty associated with the way infrastructure responds to dynamic loads. Think of forces of nature like wind, like waves, like ground motion, or ground-borne vibrations, like, for instance, vibrations induced by trains or by turbines. This uncertainty is even higher if one considers how structures interact with the soil. The less we know, the higher the safety codes in our design codes, the safety factors in our design codes. The higher the design safety factors, the higher the resulting construction and maintenance cost. Currently, we spend more money, billions per year, because we tend to over-design our structures and networks due to lack of evidence, experimental evidence, instead of using these funds to build schools or hospitals or make best use of our funds. The solution would obviously be to test at a larger scale, close to the prototype scale, and do more sophisticated tests and use better our computational means to verify our theoretical solutions. However, this is not achievable in most places worldwide. What is worse, some of the most important materials that we're using in construction, like concrete, like timber, like soil, cannot be scaled down to the size that is relevant to what we can actually test. Large-scale testing, therefore, is the single most important issue to bridge the gap between micro and mesoscale mechanics with a structural performance at the prototype scale in the real world. So what is SoFSI? SoFSI is a UK-funded, world-class facility that can provide reliable, large-scale validation for smart infrastructure across a wide range of applications for the transportation and energy sector. Finally, SoFSI was not designed in a conventional way, if I may say so. We held more than 100 meetings with industry, and we're proud to say that we adapted our initial plans, transformed our ideas, and co-produced SoFSI with our strategic industrial partners. With the RAID, we designed a facility that can change the way we deliver infrastructure so that it is safer, faster, smarter, cheaper, and greener to put the UK on the path to net zero emissions by 2050. A facility that can support the stakeholders and the state to make real-time, low uncertainty, informed decisions for network growth and crisis management, and enable the society to have better, undisturbed services during extreme events. What are our capabilities? Think big. Nuclear, for instance. Specimens up to 50 tons in this very table behind me, excited on our shaking table with an acceleration up to 2G. Seismic qualification for the nuclear industry against the very demanding Belcore specifications, a unique capability for Bristol. Safer nuclear facilities, small modular reactors under different soil conditions. Think of multiple hazards. An offshore wind turbine subjected to wind, to wave, to earthquake loads, obviously, with their corresponding joint probability of occurrence. Cyclic fatigue of the foundation soil and how this is changing the dynamic properties of the turbine so that its operation is continuous. Reliable extension of the turbine's design life now that the sea becomes more and more crowded with by wind farms. Reduction of the environmental footprint and the significant impact of decommissioning thousands of tons of steel turbine blades. Imagine structural and non-structural components, mechanical items and pieces of larger infrastructure, of buildings, of cars, of aircrafts, tested in our 6-axis hexapod that is going to be placed in front of me. In 3 translational and 3 rotational axes, up to 10G. For context, this is the acceleration that a rough pilot would experience in a dogfight. This is very high. Seismic qualification of every single piece of equipment in a critical facility. Think of natural gas, water pipelines, wastewater pipelines. where we can monitor the strengths and stresses within the soil and at the soil structure interface by filtering, by fiber optics, pressure cells, ground penetration radars, tested by using a large flexible shear stack on the shaking table. Think of retaining walls, supporting saturated and unsaturated soils, tested within the soil pit. Integral bridge abutments that have the ability to greatly reduce the maintenance cost of transportation, or even, if we brainstorm a little bit, smart, low-cost, eco-friendly, 3D printed nanomaterials. Real-time structural health monitoring. Not the Internet of Things, but the Internet of living, continuously monitored and self-healing structures, accelerated bridge construction, for instance. Imagine dynamic train loads on existing Victorian embankments and the need to verify the safety of the slopes against failure. Multidisciplinary soil structure interaction work, rail-soil track interaction dynamics on HS2 combined with the work that earth scientists are doing, and as a brainstorming and environmental envelope around the soil pit to control temperature and humidity while applying dynamic train loads. Finally, think outside of the box, even outside of this facility. Think hybrid simulation. By means of gigabit broadband internet, in which Bristol is a leader, our shaking tables can run simultaneously, even though they're geographically distributed, testing different parts of an extensive bridge in SoFSI, and another part probably tested in our other laboratory in Queen's Building in the main campus. SoFSI is the only UK entity that has the ability to combine in time and in space more than one shaking tables. And then we can also connect with other entities worldwide in Europe, in US, in Japan, in China. Today we're opening our new facility, and it's time for me to express my gratitude to a number of people. My predecessors as heads of research group, Professor Emeritus Colin Taylor for being a pioneer in experimental structural dynamics, and Professor George Milonakis, chair of SSI, for his renowned expertise and contribution. My close collaborator for the design and delivery, experimental expert, Professor Adam Crew, the SoFSI working group, particularly Raffaele De Risi, Flavia De Luca, Luke Everett, and project manager Patrick Tully. The SoFSI executive board, school manager Mary Millard, and head of school Simon Hild. Above all, I would like to thank Dean Ian Bond for being the person that steered the project decisively, providing certainty in highly uncertain times, for removing every obstacle and empowering the team to deliver. Ian, thank you. So this is the first step for a long journey for the facility and the Faculty of Engineering in Bristol, but we need to be mindful. We need to be mindful because we have a scientific and social responsibility to collectively make best use of this facility, because the ideas we put in motion today will define the next generation infrastructure in 20 or 25 years, which in turn will shape the community and the economy another generation later. How novel we are in our labs, how risky we are, how diverse, equal, and fair is the world of infrastructure that today we put in motion. This will affect the quality of life half a century later. Come and talk to us to see how we can travel in time together. But let us start this trip with a short walkthrough in our facility. That's David Williams with a video.
Hello, my name's David. We're here today at SoFSI and I'm going to give you a tour around. So here we are in the test hall. It's a 24-metre long hall, 8-metre working height and a 30-tonne crane to help us move things around the hall. So this is the soil pit. It's a 6 by 5 metre by 4 metre deep pit. It allows us to work with structures and soil and the interaction between structures and their foundations. It's surrounded by a strong floor that allows us to build bespoke test setups. This is the area where a hexapod will end up. Has an 800 kilo payload, very high acceleration capacity of 8G in all 3 axes simultaneously. Right in the centre of our test hall is our large shaking table. This biaxial shaking table has a 50-tonne payload capacity. It can manage 2G acceleration at 50 Hz, and it has a 6x4 metre working platform. The table is put into motion by 4 large actuators sat around the side of the table, and moves on 4 hydraulic clipper pads that mean it has a very smooth action. So this is our hydraulic pump room. We have a 6,000 litre reservoir, 8 motor and pump units that feed the ring main going to our test hall via a network of underground trenches. This is our service yard. It gives us plenty of space for outdoor working at the back of SoFSI. We can get big vehicles in and out of the test hall, as you can see from the doors behind us, which have a 5 metre high opening. Behind the pump room are 5 large V-blast chillers. These keep our hydraulic oil at the correct operating temperature. Coming out of the test hall, we have our breakout room. There's meeting space, refreshment space, and there's also a viewing window through to the test hall. Finally, we have our control room. This is where we operate our hydraulic ring main and equipment. It allows us to run a variety of waveforms through the software to the equipment, as well as replaying recorded real-time events. Thanks for taking a look around our new facility with me. It'd be great to see some of you here in person soon.
Hello again. We're very privileged at this opening event today to have 2 guests of honour joining us. First, we have Professor Hugh Brady, Vice Chancellor and President of the University of Bristol, who's going to say a few words, followed by Mr. John Penrose, NP for Weston, in whose constituency SoFSI sits. So first, I'll hand over to Professor Brady.
Great, thank you, Ian, and good afternoon, everyone. Welcome to our North Somerset campus, and thank you for joining us for the opening of the university's new UKCRIC Soil Foundation Structure Interaction Laboratory. I'm delighted we're joined, as Ian has said, on this occasion by John Penrose, the Member of Parliament for our campus here at Langford. John, you're very welcome. While it's unfortunate, of course, that for you, our online audience, that you couldn't join us in person today, I hope you nevertheless will leave this celebration with a real sense of the fantastic applications and opportunities that this laboratory enables. At Bristol, we're proud to be a globally engaged, comprehensive, research-intensive university, and with a civic mission at our heart. We aim to inspire, drive, and support world-leading research of the highest quality, generating a broad range of impacts through fundamental discovery-led research and ambitious challenge-led research. And we do this by cultivating disciplinary strength and interdisciplinary excellence, by being a partner of choice, and by investing in a diverse and inclusive research environment to help us attract, develop, nurture and retain the very best talent from across the globe. Our Faculty of Engineering, under the leadership of our Dean Ian Bond, has been at the vanguard of so many of the university's successes over the past few years, accommodating extraordinarily challenging conditions, accommodating a huge surge in students, I should say, under extraordinarily challenging conditions during COVID as a result of the very necessary move to teacher-assessed grades, playing a leadership role in our new Temple Quarter campus, anchoring our National Composite Centre on the Science Park, and now spreading its wings to North Somerset with the new SoFSI facility at Langford. So Ian, a special thank you and well done to you and your colleagues on yet another really important and exciting initiative. And a big thank you to Barry McGrory and his fantastic estates team, who worked so closely to deliver the SoFSI facility despite COVID and so many other pressures. And indeed, I should add our colleagues in the vet school, another jewel in our crown, who were so welcoming of their new engineering colleagues. As a global civic institution, we're committed to responding to the major social, economic and environmental challenges of our time, from climate change and sustainable cities to global health and resilience. These most pressing problems are increasingly complex, interlinked and global, requiring a truly joined-up approach to delivering research with real impact. And that means the need increasingly for collaboration and partnership, working together with partner institutions across the UK and across the globe, working with industry and policymakers, and importantly, working with local communities. And SoFSI is the newest addition to our portfolio of world-leading laboratories. As part of the UKCRIC network, it's a demonstration of that commitment to collaborative working to address global challenges which underpin so much of our research. So we look forward to working with and welcoming academic and industrial partners from across the world, and hopefully many of you watching online today, to this really special facility. I hope you got a sense from Professor Sextos of just the excitement and the importance of this venture to our community and the special challenges that the new facility is designed to meet. And now it's my pleasure to introduce the Member of Parliament for Weston-super-Mare, John Penrose, to formally open the laboratory. John.
Professor, thank you very much. Ian, thank you very much. And a huge welcome to our online audience here today. I only wish that the people who are watching online could be here in person. I'm sure many of you either will have been here during the development or will be here very shortly, but this is a cathedral space. It's awesome to walk into, and I'm deeply honoured to be here at the moment when we are opening it and it's starting its journey of discovery, if I can put it that way. And it's particularly good news, not just for Langford, for North Somerset, for local brains, local research, but also local businesses, I'm sure. It's also important because of the key field in which it's going to be doing its work. Because with enormous changes in our world, including things like climate change, understanding what's going on under our feet, around our structures, making sure that we can preemptively intervene when necessary, when risks that you can't see are building up, which you would not otherwise be aware of, or where maintenance may either be due early or not due yet and be safely delayable. All these things are absolutely essential for people not just in North Somerset, not just in the UK, but actually globally, right the way around the world, to understand and to be able to manage much more effectively than we have been able to in the past. And it is only through cutting-edge research of the kind that's going to be happening here that we can do those things. Added to which, looking behind me, it's got some amazingly good toys as well, and they are world-class and very, very large toys. So if you don't like anything else, just come and look at those, because it looks superb. Now, in keeping with the fact that the toys are very large and therefore cutting a ribbon would probably be sissy, I'm therefore just simply going to say I'm delighted, honoured and very, very proud to declare this facility open.
So thank you very much, John. Thank you very much, Hugh. We're now going to give you a bit of an insight into what the facility offers with a short video. SoFSI is a unique world-leading facility that provides dynamic testing at very large scale. Things to do with energy generation, whether that's nuclear or renewables, the development of new bridges, new infrastructure, new large buildings, is part of a nationwide initiative of approximately £150 million that's being rolled out across the country to really give that infrastructure development that the UK needs to be a world player.
We need such large-scale facilities because our structures are aging, our structures are falling, the climatic conditions and other natural hazards are increasing. Therefore, we desperately need to inject smartness into our systems and make sure that with a reduced amount of money, we get the best possible performance for the society and for the community as a whole.
From components, for example, in hospitals that cannot be subjected to high vibration and that are highly expensive, or application for robotics, where basically tiny movement can completely mess up the functioning of the whole system. and building resilient structure and infrastructure to earthquakes, like schools or other critical facilities.
The facility includes 3 different areas, 2 shaking tables and 1 soil pit. The large shaking table is a 6x4 platform that is able to apply harmonic and random dynamic loads on very large specimens up to 50 tons. Next to it, we're installing the hexapod. Small but super powerful, mini monster as we call it. It can accelerate the specimens up to 10G for frequencies that exceed 50 Hz. The soil pit is something different. It's an underground space.
A huge hole in the ground, very deep, with a lot of concrete around, that allows you to pour sand and soil and simulate what really happens in, for example, in the abutment of a real bridge, but in a highly monitored way. This can mean we can inform and improve our design practices and assessment practices thanks to the information that we get from the experiments that we are running here.
Through more than 100 interviews and talks and collaboration with industry, we hope that we have produced something that is not only interesting for us, it is also useful for the industry and useful for the society.
This facility will provide new routes to net zero sustainability across the whole infrastructure, getting there faster, cheaper, quicker. It allows us to partner with partners across the world, develop this next generation of technologies. It'll bring new engineers into the industry, really sets us up to be a global player in the development of next generation infrastructure. So hello again. So we have a few moments for a question and answer session. Please feel free to enter your questions into the Zoom facility if you are online, and we will endeavour to answer them, if not now, after the event. So thank you. So the first question I'm going to ask is to Flavia. Flavia De Luca is a senior lecturer in earthquake engineering at the University of Bristol. Flavia, what are the first experiments that are due to take place in the SoFSI facility?
Hi Ian, hi everybody, thanks for your question. The first project we will be running here in SoFSI is Plexus Plus. It's a UKCRIC funded project. Actually, is a follow-up project from the EPSRC project Plexus, and we are developing this in collaboration with the University of Birmingham and University of Southampton. The main task we have for this project is to test a quasi-real scale integral abutment in the teeth down there. It's gonna be a scale up of some preliminary tests that we have been doing at the Queen Building laboratories, and we are going to learn more about the best way to design integral abutment that are a typology of bridges that allow low maintenance, so can be very cost efficient if implemented. This is not the only test, the only project we are planning to run very shortly. We also recently awarded an EU project. I don't know if Tassos wants to give a few words about it.
Of course, thanks very much, Flavia. So I'm delighted to announce that maybe a couple of days before our grand opening, SoFSI and the University of Bristol were awarded a European grant for transnational access, which actually gives the opportunity to international researchers come and conduct high-quality, large-scale experimental testing at our premises. This puts SoFSI directly at the very heart of the European research, and we are very pleased that we'll have the opportunity to invite our colleagues and offer our services at SoFSI.
Thank you both. So my second question is to David Williams, who's the technical manager of the facility. David, can you outline the technical capabilities of the SoFSI facility?
The soil pit particularly, which Flavia mentioned making use of, it's a 6 by 5 metre by 4 metre deep pit. One end of it has a 2 metre deep trench that we can mount actuators in and load below floor level, which we'll be doing for the Plexus Plus project. We've currently got 3 actuators associated with the pit, with the scope to expand our portfolio as needed as we go on. All 3 have a 1 meganewton load capacity, one of which is dynamically rated. Above the pit, we've got a headroom of 8 metres, so we can build quite tall structures. So, for example, we have plans to look at offshore wind turbines and piles for there, so that would involve quite a tall structure in the pit, and that allows us to do that. In the outside wall, next to the soil pit, there are also some ports to allow us to bring auxiliary hydraulic power. For example, with the wind turbine that I mentioned, we could provide excitation to the top of the structure to simulate turbine blades moving around. Around the pits, we've also got the strong floor, which you may have seen in the videos. That allows us to build reaction frames next to and over the soil pits for instrumentation or for loading from actuators. So it's quite versatile.
Thank you very much, David. So just thinking about the wider aspects of UKCRIC, a question again for you, Tassos. How does this complement the other laboratories that are developed as part of the UKCRIC initiative?
Yes, that's a very good question, actually. The UKCRIC framework was designed from the beginning to facilitate collaborative research in a complementary manner, which means that the facilities have been designed from the beginning to be able to facilitate multidisciplinary work of other researchers and between the different entities. For instance, we work very closely with infrastructure for the facility for buried infrastructure in Birmingham. We work very closely with the University of Southampton, which has great expertise in structural engineering, HS2 applications, and also a large centrifuge. Overall, there are other opportunities through common programs that are run within the UKCRIC until this also evolves as an institution to facilitate the next day after all these great facilities have been built. So we have a great vision and aspiration to work very closely with our colleagues in other UKCRIC entities and with other colleagues that are now part of affiliated universities that are joining the family of UKCRIC.
Thank you very much, Tassos. A question for you, Flavia. Building on the question I've just asked Tassos, how does this new facility complement the existing facilities we have at Bristol?
Thanks, Ian. Actually, when we have been designing and conceiving the SoFSI lab, it has been designed to complement our facilities at our current facilities, so our current lab. In particular, the shaking table, this shaking table with a bigger payload, larger size, will allow us to scale up dramatically and significantly the test capabilities we have. On the other side, the hexapod, so the smaller high acceleration shaking table that we will have in this lab shortly, will allow to complement on the other side the current lab we have in Bristol. And finally, the pit will be the facility that will be shortly allow us to test semi-real scale soil structure interaction problems with the actuators and with the actuators that we have. Thanks.
Thank you, Flavia. And a final question for you, Tassos. If people are interested in working with you and exploiting this facility, what's the best way for them to do that?
Well, the best way is to get in touch with us, obviously with the people who they can see here, but also with Adam Crew, with Patrick Tully. We're very happy to discuss further. There are different avenues of collaboration, obviously. The obvious academic way, let's say, is to pursue joint research through research programs, but that's not the only one. We can work very closely with the industry to test experimentally against problems that are very important for our industrial partners. So you can either bring your ideas to us to work with us, or we can work for you. There are two different ways. And obviously, we can even go outside of this laboratory, utilize the expertise that we've got in structural health monitoring and field testing to be able to collect data, process them, and interpret them for you. There are several ways, therefore. You can just follow our announcements on the website, and we'll be delighted to work with you.
Thank you, Tassos. So it just remains for me to conclude this afternoon's event. I'd like to thank our guests and speakers for taking the time to join us and help celebrate this opening. As you can no doubt imagine, the design and development of this unique facility has involved many people, far more than you've seen this afternoon. And so on behalf of the faculty and the university, I would just like to thank the following people and organisations. So colleagues in the School of Veterinary Science, who have welcomed us as new neighbours on the campus. The University Capital Development Team, who have overseen the project, led by Barry McCrory, but particular thanks to Luke Everett, who's been the project manager for this major activity. The architects, Stride Treglown, the project engineers, Arup and ACOM, the project managers, Curry Brown, the quantity survey team, Faithful and Gold, the main contractor who undertook most of the substantive construction work, Andrew Scott Limited, and our main equipment supplier, Servotest. So as the current external situation improves, we will be happy to host tours of the facility in the near future. Contact details for arranging these will be provided in a follow-up email to those attending, to those who've attended online after the event. However, in the meantime, if you do want more information, please refer to the SoFSI web pages on the University of Bristol website. And all that remains for me to do is to thank you all yourselves for joining and spending the time with us this afternoon, and I wish you all the very best. Thank you.